Hi! This instructional video is about proving the quadratic formula, the proof of the quadratic formula, given the standard form ax squared plus bx plus c. Now, if you're taking a standardized test, sometimes they might ask you where along the steps will you see a mistake. So you might want to keep a keen focus on what I'm showing you. And also, you might want to keep track of what are the algebraic properties that I am using in order to prove the steps along the way. Okay? So, check for mistakes and keep mind of the properties that is being used. So here we go. In order to prove it, the step one is if the leading coefficient A is other than a 1, you have to make it into a 1 by dividing it out. So first, division property of equality of the coefficient A. What remains is then, as the A simplified from the leading coefficient, x squared is equal to b over a x plus c over a equals, well, any numerator with a 0 is simply a 0. Oops, that's a plus right here. Now from this point on, I'm going to use a thing called complete the square method. Complete the square method. So here, division property of equality. Here, we're going to complete the square. Okay? In order to do that, I'm going to move the c term over to both sides of the equation, subtracted. So that's a subtraction property of equality in order to complete the square. So we end up with x squared plus b over ax plus, and I always ask the students, leave it blank, is equal to leave it blank minus c over a, because we're going to put a perfect square c term here, but whatever we do to one side of the equation, we got to do it to the other. Now, where do we get that c term? Okay, and the trick is take half of the b, so the b term of the standard form is b over a, and to take half of it, you multiply 1/2. Take half of the b and you square it. And whatever that is, that's where you put it on the c term. So if I evaluate the inside of parentheses, we get b over 2a squared. And since you did it on the left side of the equation, you got to do it to the other. Next step, in a part of completing the square, you got to factor. So let's factor the trinomial here. And as we do this, let's evaluate the square over here. So we got b squared over, well, the rules of exponents says the 2 goes to the b, the coefficient 2, and the a. So we get 4a squared minus c over a. And on the left side, what times what is x squared? Is x and x. What times what is b squared over 2a squared? Well, that's b over 2a times another b over 2a. And what must their signs be? So if you add them, it becomes b over a. They both have to be plus. Since it's a perfect square, it's a special product property, they will always be identical binomials. Now, since they're identical binomials, we could write as one expression as x plus b over 2a squared. And while we do that, let's evaluate what's on the right side. To add or subtract two quotients, we have to have a common denominator. So we're going to find the common denominator. There it is. And the common denominator between 4a squared and an a is, in fact, 4a squared. Now, this is already a 4a squared, so the numerator b squared stays the same, minus, now how does this a become a 4a squared? We have to multiply the 4 and an additional a. But whatever you do downstairs, you multiply to upstairs, so you get 4ac. Okay, now we're going to solve for x, and to reduce the clutter, I'm going to rewrite the expression or equation. In order to solve for x, we're going to do the inverse of a square, which is a square root. And of course, square root of a square, when you do that, the radicand comes out. And anytime you square root any number, there's a possibility of being a plus or a minus. And at the same time, I'm not sure what a b squared minus 4ac square rooted becomes. But I do know what a square root of a 4a squared is. Square root of 4 is 2. Square root of a squared is a. Let's raise that up a little bit. There we go. There we go, a little more. There. Okay, now I'm going to continue on over here. So if I copy this over here, x plus b over 2a is equal to plus or minus square root of b squared minus 4ac all over 2a. Now to solve for x, I'm going to subtract b over 2a to both sides of the equation. So it's a subtraction property of equality, just like when I was getting rid of the c over a term. And as a result, on the left, b over 2a is canceled out. I get x is equal to negative b over 2a plus or minus square root of b squared minus 4ac over 2a. And since these two quotients, they both share a same denominator, I could write it as a common denominator expression as negative b plus or minus square root of b squared minus 4ac, the entire expression over 2a. And there is the quadratic formula. So once again, to recap, remember some of the properties that we have used to prove the quadratic formula. We had to divide, we had to complete the square, we had to find the common denominator, we had to factor, and the rest is a repetition of the same process, okay? So keep that in mind. You might want to try this over and over on your own and be familiar with the properties and the complete the square methods. Good luck!